Hi friends, welcome back to Amplify Academy. We're trying to learn grade 10 polynomials. We started with some basics in our previous videos. And in this video, we'll be learning how do we represent a polynomial on a graph, okay? And not only that, if the graph is given to us, we'll figure out how does a polynomial will be looking like, or what kind of polynomial will it be. So as you know, polynomials will have different sort of degrees. Some polynomial could be a linear polynomial, some could be quadratic, right? So linear, that is quadratic, and it could be a cubic polynomial as well. These are nothing but polynomials with the powers. So for example, when I say linear, I can say example as x plus 5 or 7x plus 3 or anything of sort where the power of the variable is 1, right? So this such examples by the power, it could be fractional form or negative minus 2 by 5x plus 3 by 2. It's absolutely fine as long as the degree is 1, it's called as a linear polynomial. Sometimes we could have a quadratic polynomial where we will have expression containing square in it, square in the variable form. For example, x squared plus 7x plus 10. Okay, sometimes we would have the negative terms also included. It could be absolutely fine to have negative terms, minus x squared plus 5x plus 3. So here the terms could be negative. What is important is that looking at the power of the variable. The highest power is 2. So hence this is called as quadratic. In cubic, same thing happens. You'll have to look at the polynomial's power. If it's 3, for example, x cubed by 5 plus 7x squared plus 2x plus 1, or even if it's just 3x cubed, this is also still a cubic polynomial. Don't have to worry about that. Just because it does not have any other term, it doesn't make it any less of a polynomial. Just have to make sure that is a variable and the power of the variable is 3. That will make it a cubic polynomial. That's simple as that. Now, graphical part of it. Now, you know that the degree of all of them as it's linear, quadratic, cubic, the degree is for very clear. So degree part, for degree for linear, it is 1. For degree for linear, it is 1. For quadratic, it is 2. For cubic, it is 3. That is how we understand the polynomials. That's how we differentiate different polynomials based upon the power, the degrees, technically speaking. Now, we will understand how do we represent them on the graph, or when we represent in the graph, something called as zeros. We'll find something called as zeros because this is where the actually polynomials will make sense to you. Until now, you're just seeing a bunch of expressions in front of you, which might or might not make sense to everyone. It's difficult. It's a dry subject sometimes you might feel. So when you see things visualized, it makes more sense. So the zero is those values when you put back in the expression in terms of x, replace the values, some particular values for given equations, you'll get the answer as zero. That's why it's called zero of the polynomial. Okay. For linear, we will have less than or equal to 1 zeros. Number of zeros is that the graph x plus 5, if I plot it, it might intersect the x-axis once or maybe less than 1, that is 0 times. It could be 1 or less than 1. That's the meaning of it. That's what information we get. And how do I know that? Because it's a linear. Because it's linear, so its number of zeros could be less than or equal to 1. If it's a quadratic, it'll be less than or equal to 2. Because it's quadratic, quadratic's degree is 2, right? So based upon that, the number of zeros it could have will be maximum 2, or it could be 1, or it could be 0. So it could be uh, 2 or less than 2. Don't think of numbers below 0, okay? That's not possible. We're just saying that number of times the graph intersects the x-axis. Why x-axis? Because we're having all the variables in terms of x. That's why. If it's a cubic polynomial, then again, the number of zeros it could have maximum is 3. It could have three zeros, or it could have two zeros, or it could have one zero, or it could have no zeros also. So all we know is that maximum it can have, the other way of writing this is maximum it can have three zeros. That is three, or it could be having two zeros or one zeros, or sometimes it not have zeros also. Possibly that's very, very rare occasions. Okay, but that's how we understand a cubic polynomial. It's very, very rare to have no zeros. That's not probable. But for your understanding from begin with the basics part of basics, it's thus. All right. Now you might have understood a bit of it. Honestly speaking, it's not something straightforward, well, like an arrow. We'll have to think, process, and also let's move to the next part, visualize. So I've given you some explanation part over here. Now this is about finding the graph, learning the graph, and from the graphs, we'll also find the polynomials. That part is something we'll focus on now. We'll move on to a graph, and we have a bunch of polynomials in front of you. Can see here. So these polynomials are of different degrees. So first one, as you can see, it's a linear polynomial x plus 3. As the degree is 1, and as I told you, if the degree is 1, it can maximum have 1, 0, right? So let's plot this. If I plot this, oh, I can see this graph coming in blue color line. So it is intersecting the x-axis at this very one particular point. Hence, I told you it can have maximum 1, 0. Sometimes the graph, could be very different. For example, I can just write just example. I'm saying a 3. So if I just write expression polynomial uh, uh, 3x to the power 0. So 3x to the power 0 is same as 3, yes, you know it. And you can see a black line going there. So this line is not intersecting the x-axis at all. So this is the second example I told you that if it's a linear polynomial, technically this is not a linear polynomial, this is a zero polynomial. So here there is no, what is it called, zero at all. It does not have zero for this particular question. Linear polynomial will have at most 1, 0, or sometimes it might not have zero at all. Okay. Next, let's move to quadratic polynomial. So in quadratic polynomial, you can see here x squared plus 7x plus 10. The degree of it is 2. The highest power is 2. Now let's plot it. If I plot this quadratic polynomial, you will see a very interesting shape, a U-shaped graph. You can see a U-shaped graph. And this are very special only to quadratic expressions. Sometimes it could be negative ones also. You can see the next expression right in front below that, minus x squared plus 3x plus 5. No? So here I'll just tweak the sign of the first term. The x squared term, I'll tweak its sign as negative, and I get the whole polynomial reverse. So when the x squared term is negative, right? So you will find the polynomial as reverse U or N-shaped. We call it as the first one, the red one, as parabola. The N one, the N-shaped one, is called as hyperbola. So these are the zeros. And if you want to pinpoint the values, you can see the values over here. It is -5 and -2. So these are the zeros. It means when I put back the value of -5 in the expression, I'll get the answer as 0. If I put the value of -2 in the expression, I'll get the answer as 0. Okay, that is something later we'll be learning, the zeros of the polynomial separately, but the graph can tell enough of things about a polynomial. Suppose if I just give you a graph without explaining, without giving you the question, and I tell you that what kind of graph is the red one. Okay, so you can see the graph in front of you, the red color one. So clearly, as it's a U-shaped graph, as a parabola, so it will be a quadratic polynomial. And the zeros of the graph are -2 and -5 and -2. So these are the zeros of the polynomial. And later series we'll learn a formula by which we can produce the polynomial once we have the zeros of it. This is the thing which you need to focus on. First objective is to understand what kind of polynomial. It's a quadratic polynomial. We'll just stick on to that basics for now. Now, next part. Now you're having a cubic polynomial. So cubic polynomial in front of you can see it. This one has the power as 3. The highest power is 3. So when I plot it, I can see something like an S-shaped or reverse S-shaped graph. And this graph is a cubic. And as I told you, the number of zeros it can have is less than or equal to 3. So it can intersect the x-axis at one point, sometimes at two different points, sometimes at three different points, but never zero times. That's going to be a very important part. Less than or equal to 3. This is a simpler way of remembering it. As the polynomial's power is 3, the degree is 3. So number of zeros it can have is maximum or equal to 3. That's the expression. No matter what is going to be your coefficient. Okay. No matter what is your coefficient, is it just x cube or is it 5 by 2 x cube minus 8x squared plus 2? So it doesn't matter what kind of polynomial. So here you can see an expression which has three different zeros. You can see the points of the zeros where it is some negative fraction it is, decimal, negative decimal values. And these are the three different. So if you look at the graph and you see that the graph is like a S-shaped graph. So it has three different zeros. So even if you see it's S-shaped graph, you can directly tell it's a cubic polynomial. Okay, that is the meaning. And you can tell it has three zeros as the graph says. In the case of question number 4, how many zeros does it have? It has only one zero. That is this particular value. So by now we know that how do you figure out just by looking at a graph how many zeros does it have and what kind of polynomial is it. This is a beautiful graph when I put everything together. It's the fun thing about maths. With this, we'll stop here now. Thank you.